Welcome to 1010 with Yuan. You can call him Brian. He is from the College of Computing, an assistant professor in the Department of Applied Computing and Computer Science. His research interests span the field of deep learning, cloud computing, security, and privacy. In this talk, Dr. Yuan will discuss his research in trustworthy machine learning, as well as some of the ongoing research projects in his lab.
Okay, thank you for your introduction. Yeah, hello everyone. So I'm Brian Yuan. So yes, I'm happy to give a talk about the trustworthy machine learning. So here's some information about me. So I'm a assistant professor in applied computing and computer science department. And I'm teaching two courses this semester, machine learning and machine learning in cybersecurity. So my research mainly spans the field in three areas. So machine learning, security and privacy, and cloud edge computing. So in today's talk, I will discuss the intersection field between the machine learning and the security and privacy, which is trustworthy machine learning. So it is hard these days to escape hearing about machine learning in the news, on the social media, even in the cafe conversations. So many applications we use in our daily life actually are machine learning or even deep learning empowered. For example, you may use the face recognition applications when you take a selfie or to unlock your cell phone. You may use the Google Translation to understand some foreign language. Okay, you may use some like personal assistant applications like Siri or Google Assistant to set up your daily meeting. Or you may just like me who don't want to waste time in commutes. Then the Tesla is my dream car because of its self-driving features. So really this machine learning, this deep learning applications is around us everywhere we look, touching every facet of our human existence. But when we use this machine learning in our daily life, can we really trust the deep learning? So in today's talk, I will briefly introduce some topics, some work we just did recent years about trustworthy machine learning. So I will give an overview of this work. So if you are interested in any of this work, please feel free to interrupt me or discuss me offline. So first, let's take a look at a security problem in the deep learning, which is called the adversary example. Maybe many of you are very familiar with that. So the adversary example are the input to the machine learning models that an attacker has intentionally designed to cause the model to make a mistake. For example, we can build a machine learning model to do the image classification. For example, to classify this panda image. And actually, we can build a model very well and then to correct this image as a panda image. But suppose we add some small adversarial noise to this image. And I think everyone agree with me that this image is still a panda image. But the machine learning model will classify it as a given, which means that the machine learning model will be fooled. But who cares about panda? So let's take a look at some real-world applications, like how do we attack the stop sign? For example, on the left hand side, let me stop this video. We can see that we add some stickers or graffitis on this stop sign. And thus this stop sign will be mislead in some time frame. So this stop sign, we can see that can be misclassified as the limit sign at some time. But on the right side, if the image is not perturbed, it's the original image, the benign image. Actually, the machine learning model can predict this stop sign very correctly as a stop sign. So this is a serious problem in the current machine learning algorithms. And also in our previous work, actually we target at a new scenario called syntax recognition, which can recognize the text in the natural things. They can By using the deep learning, machine learning algorithms, building these deep learning models, we can recognize the text in very complex background, in very complex scenarios like this. But we find out that the adversary examples actually exist in this syntax recognition problem. For example, in the original image, the deep learning model or machine learning model can classify this imported, the image with this word imported as imported. But if we add some noise to the image, and although we human can still recognize this image as imported, but the machine learning model will classify this image as business. And also, we find out that it is not non-trivial to directly apply the existing adversary attacks to the syntax recognition task. So here we leverage some topics in the Bayesian neural network to handle the uncertainty in the modeling. So due to the time limit, if you are interested in this topic, we can discuss it later. So next, let me formally introduce this adversary example. Here is the common paradigm of this machine learning. So suppose we collect a bunch of training data, including some input samples plus some labels, and use this training data to train some machine learning or deep learning models. And after we train these models, we can use some test data and feed this test data into the machine learning models to get the prediction. And actually, in the adversary example, we carefully temper the test data so that we make a model behave different on the test data, or the model's prediction will be changed after some perturbations on the test data. This is called adversary example. Let's take a look at another topics in the trustworthy machine learning, which is the data privacy. So all these machine learning models are data-driven, which means that we need to use some training data to train our models. But when we release these machine learning models publicly, actually we will find out that actually this training data might be exposed as well. For example, let me take I think many of you may use this auto-completion system when you use some virtual keyboard, or when you compose an email using Gmail. And there's a very nice feature in this software which is called auto-completion. It will auto-complete the word, the sentence, the words or the characters when you typing. Okay, and this application actually based on a type of machine learning models called language modeling. And the model actually will learn from your typing history and help you to predict the next word or the next character you're gonna type. Okay, but on the other side, if you type some confidential information, for example, your social security number in this auto-completion system, for example, you type my social security number is blah, blah, blah in these applications. And this machine learning model will remember all this confidential information. So next time when you or some bad guy type the same thing like my social security number is, and then the auto-completion system will auto-complete the rest of the words, which is your confidential social security number. So which is a very serious data leakage in the machine learning model. And also this data leakage can be found in other machine learning tasks like the face recognition system when we train a face recognition system. And this facial recognition system actually can expose some facial image of its training data. And in our recent research, actually we find out that such data leakage happens even when we have some privacy preserving techniques called federated learning. So federated learning is a very popular technique right now to enable the multiple participants to collaboratively train a machine learning model on some decentralized devices with the privacy preservation. But we find out that such data leakage actually happens in this federated learning paradigm. So this is the second issue we talk about, the data leakage in the machine learning. And third, we find out that not just the data could be leaked through this machine learning paradigm. Actually, the model itself could be exposed when we train the model, when we use this machine learning model. So right now, many cloud service provider like the Amazon, AWS, Microsoft Azure, or Google Cloud, IBM, they all provide the machine learning as part of their cloud service called machine learning as a service. So some user can send the query to the service provider and then get the prediction about the query. For example, the service provider can provide a prediction using their machine learning service and to say that this is a bird image. But actually in the model extraction attack, the attacker can pretend themselves as a normal user. And through the several queries and through the predictions provided by the service provider, the attacker actually can steal a model with the equivalent function with original model, machine learning model. So why this model extraction is important? First of all of these cloud service provider actually leverage or purchase a lot of machines equipment to build their machine learning models. And they may hire some AI experts, machine learning experts to design their models, to design their some representative features in their models. And also, we all know that the machine learning are data-driven, so we need a lot. The service provider need to collect a lot of data to annotate a lot of the data to build a machine learning model. So all of these are time-consuming and very costly. However, if some adversary or attacker can steal the model, so first of all, this stolen model has a very high business value. For example, we can steal like a model to predict a stock market, right? And also, second, since the model stealing attacker do not need all these requirements to build a model. They just need to send several queries, and based on the prediction, they can provide the same service, but with a much lower prices. So in our previous work, actually, we successfully extract very deep neural networks. Even without some auxiliary data, we successfully conduct this model extraction attacks. So here I will not go into the detail about these works. So here just several takeaways about this kind of 10-10 talk. So first of all, in this talk, I talk about the security issue in the trustworthy machine learning, including the adversary examples and many other security issues related to the such as the pointer attack or backdoor attacks we haven't discussed yet. And also in today's talk, we talk about the privacy issues in the trustworthy machine learning, such as your training data could be leaked, could be exposed in the machine through the machine learning model, and the model itself could be exposed. And also many other related attacks, such as the membership inference attack. We just submit a paper to talk about this membership inference attack last month. And also there are many other issues in the trustworthy machine learning, like the misuse of the machine learning algorithm. For example, I think you must heard about that deepfake, which can generate the fake image, fake audios using this machine learning algorithm. So that's a very bad use of machine learning, and that's the use we need to prevent. And also many other issues like the fairness issues or the explainability problems in the machine learning. And actually in the trustworthy machine learning, we have many more problems. So actually the effective countermeasures about this trustworthy machine learning are urgently needed. especially in the safety critical applications. So basically, when we consider using the machine learning applications, using the machine learning models, so the performance of the model is not only the matrix we need to take care. Other many very important aspects like the trustworthy machine learning, we need to consider when we build these machine learning models or deploy the machine learning applications. So that's pretty much about this trustworthy machine learning. So next, I will introduce my other works in these three areas. So today I talk about this trustworthy machine learning So in this intersection between this machine learning and the security privacy. And also in this area, I did some work in how to use this deep learning for the cybersecurity problems, such as how to use the deep learning, machine learning for denial of service detection, malware detection, or web anomaly detection. And also, I did some work in improving the general machine learning algorithms or deep learning algorithms. For example, I proposed a module called generalized batch normalization to accelerate the deep learning training. So batch normalization is a very popular technique in deep learning. Also, I collaborate with my colleague in the astronomy department for some deep learning for the astronomy analysis. And also another thing I want to emphasize is that the machine learning or deep learning actually provides us some principal set of mathematical, statistic, or probability methods to learn the knowledge from the data. But when recent years we talk about the big data, actually it is equally important to harness the volume, the large volume, large velocity, variety of this big data. So here actually we leverage the power of cloud computing and edge computing, like the Docker containers, Kubernetes, Kubeflow, this kind of cloud computing techniques to empower the machine learning. So here we build a intelligence cloud platform for the deep learning algorithm applications. And also, I did several works in the resilient cloud computing to improve the resiliency, to improve the availability, reliability of the cloud computing platforms. And the last is several of my ongoing projects related to actually in the middle. So in the intersection between the machine learning, security privacy, and cloud or edge computing, including like the federated learning. So how can we create the collaborative intelligence among the edge devices while preserve the data privacy on edge devices? So we work on this called federated learning topics, and also many related topics such as the privacy preserving on-device AI or intelligent wireless sensing. So these are the topics I'm currently working on. So let me know if you are interested in any of these, and thank you. So any questions?
Hi, I'm just curious about the autocompletion that you have mentioned.
Sorry, can you say
About
again?
The autocompletion that you have mentioned. The autocompletion.
Oh, okay. Autocomplete. Yeah. So let me.
So I'm just curious. It's not probably not directly related to what you are doing, but are you doing any specific? Are you using any specific like string matching algorithms for this autocompletion system, or it didn't matter for you and you just used some?
Oh, so for this auto completion, we use this language modeling, which is built upon the neural network, recurrent neural network.
But just to match the strings, did you use any specific algorithms or software to do the string matching?
We don't need to we don't have specific algorithm to do the string matching because the string, the length of string is not a very long string.
Oh, I see. Okay. Yeah, thanks.
So, Brian, can you share your vision for the future of AI and the cybersecurity, like in the next 5 or 10 years? How do you envision the future?
That's a good question. So one aspect I'm very interested in. So actually there have been many works in the trustworthy machine learning, in the intersection between like the machine learning and the cybersecurity. How can we like improve the security and privacy in the machine learning algorithm? But one potential future direction I can imagine is that I mentioned here called on-device AI. Because right now, almost all the work on the trustworthy machine learning assumes that the machine learning is running on some cloud server or on some powerful server. But actually, so in recent years, many machine learning applications actually are deployed in our smartphones, in some edge devices, in the IoT devices. So there are several specific. So on these devices, actually we have less resources and less security features on let's say smartphones or IoT devices. And how can we protect the machine learning algorithms on machine learning applications on these devices? That would be very interesting.
I have a question. Is there a significant difference between machine learning and artificial intelligence?
So that's a good question, and there are some debate in between like the machine learning guys and the artificial intelligence guys. So in my point of view, so the machine learning is a subset of AI. So yeah, so it's my point of view, but machine learning is more related to the statistics and the probability. The artificial intelligence is, I would say, has less part of this statistics and probability things in the artificial intelligence. If we want to tell the difference between these two topics.
All right, if there are no more questions, we'll end it here. Thank you very much, Dr. Yuan. This was very interesting. And for the rest of you, thank you for coming. It was good to see you. Enjoy what's becoming a sunny evening, and we'll see you tomorrow at graduation.
Thank you.
Bye.
Thank
Bye.
you.
Thank you. Bye-bye.
Bye.